So welcome everyone to the GLEON Student Association workshop titled 3 Simple Guidelines for Science Communication. So my name is Benjamin Kraemer and I'll be leading this workshop. I'm from the University of Konstanz, where I'm a postdoc. And I've really benefited immensely from GLEON in general, both as a student and now as a postdoc. You know, it's really opened doors for me to new questions and new collaborations. But I've always felt a strong need to do more to give back to GLEON. So that's why I'm here giving this workshop. So as an early career researcher in aquatic science myself, I don't have a degree in science communication, but I am passionate about it as a topic, and I've read widely on this specific issue. So I'm happy to kind of channel what I've read and my passion for this topic onto you through this workshop. And there are no prerequisites. So you can do the workshop alone or preferably in a group of 2 to 5 people. So if you want to stop the video now and find some friends or colleagues to do the workshop with you, that'd be great, but it's not necessary. You can do it alone. But each of you will need to have something to write with, whether it's typing on a laptop or your phone or a good old-fashioned pencil and paper. So I'm really looking forward to help you have some fun, work hard, and to think deeply about effective science communication. Now, this workshop will take about 3 full hours, plus or minus 1 hour, depending on how fast or slow you move through the material. But the total runtime of the 4-part video series for this workshop is more like 1 hour. So the difference between the length of the workshop and the length of the workshop videos arises because you'll be pausing the videos often while you complete certain parts of the workshop. Now, this workshop has a theory component, a practical component, and those two will be bracketed by a writing exercise at the very beginning and another one at the very end. So let's just dive right into the first writing exercise. So 3 to 5 sentences, please write down how you would describe your work to someone that you just met at a GLEON meeting. So you can go ahead and please pause the video now for you to complete this exercise. So you should have now finished writing the 3 to 5 sentences describing your work to someone that you just met at GLEON. And we'll be coming back to what you wrote later in the workshop. But I want you to just set that aside for now and focus your attention for now on the video. Really and the very first thing I want you to do here is to take a moment and try to recall an example of effective communication that you witnessed. It could be scientific or otherwise. Maybe you saw a presentation recently that you attended, or you recently read an article, post on social media that you came across, or maybe even a movie that you watched where the communication was really effective. So what made it effective? Chances are it followed one of the 3 simple guidelines for science communication that we are going to be learning about today. For me, one of the first examples that comes to my mind of really effective science communication is flatten the curve. So if you're not familiar with this idea, it came out kind of early in the COVID-19 pandemic with a pretty simple message. And that message was, we cannot stop the pandemic. But what we can do is slow its spread so that we don't exceed the capacity of the healthcare system. And in order to do that, we have to wash our hands, not touch our face, and stay home when we're sick, and wear masks, that sort of thing. So at the beginning of the pandemic, this idea of flatten the curve and this comic that I'm showing here that accompanied that idea really spread rapidly across media, social media, and became a kind of a dinner table topic of conversation. And to me, this idea and how quickly and rapidly it spread really demonstrated that society, including public health, depends on the effective communication of science. But I'm afraid to say that science often falls short of this noble goal. So take, for example, the overall readability of the scientific literature, here measured from a wide sample of scientific papers using what's called the Flesch Reading E-score. And this score is just a metric that depends on the average length of the sentences and the average number of syllables per word in a given sample of writing. So high values means that it's very readable, and low values means that it's not very readable. So what this graph shows is that around the 1900s, the reading ease score matched what could be expected for someone who has some college level education. But as time went on, the readability of scientific literature decreased substantially, so that today, you basically need a graduate degree in the specific field to be able to understand primary scientific literature in that field. And this means that the vast majority of scientific literature is inaccessible to scientists outside that field. And it's inaccessible to policymakers, inaccessible to the public at large. And it's not just scientific literature that has this very low readability. So for instance, the Intergovernmental Panel on Climate Change, the IPCC, every time they write a report, they accompany it with a summary for policymakers. Now, this is the part of the IPCC report that is meant to guide policy decision-making. And it's also virtually unreadable for most policymakers who don't have a degree in climate science based on these Flesch Reading E-scores. And it's getting worse with each successive IPCC report. So you'll notice that from on the left part of this figure, from the red bar showing a relatively high reading E-score to the yellow bar shows the trend over time in the readability of this summary for policymakers. And because this is very difficult for most to read, instead, policymakers and the public often are forced to rely on the other sources shown in this graph. So scientific magazines, quality newspapers, and tabloids. And we rely on those sources of information about the latest climate science. And the problem is that those sources often distort or disregard or exaggerate the science that they report on. So what can we do as individuals to help remedy this problem? So each of us can actually have a part to play. If we become better communicators, it won't just help society function, but it can also help us as individuals to get more papers published and get those papers cited more often, to get grants accepted, and even to advance our careers. So today, we are going to work on 3 simple guidelines for improving our ability to communicate science. And those 3 ways are telling a story, focusing on one thing, and using shared language. So these 3 things are based on research from scientific communication experts, and these 3 things are consistently reported by those experts as being very important for the effective communication of science. Now, for each of these, we'll do a short exercise that's going to demonstrate the principle, followed by a bit more explanation of what it means. Then we're going to apply these principles by analyzing a series of 10 writing samples. So to start learning about these 3 impactful skills, please advance to part 2 of the science communication workshop.